Using the mean, standard deviation, and empirical rule to check for unusual result in a binomial experiment. According to the Experian Automotive, 35% of all car-owning households have 3 or more cars. A researcher believes this percentage is higher than the percentage reported by Experian Automotive. He conducts a simple random sample of 400 car-owning households and found that 162 had 3 or more cars. Is this result unusual? The problem states that in the population, 35% of all car-owning households have 3 or more cars. And in this sample, he found 162 out of 400 that represent approximately a little more than 40%. The problem is asking if this result is unusual, assuming that the probability that a household have 3 or more cars is 35%. We solved this problem in the PowerPoints, and also I explained this problem in a video. Let's solve the same problem using technology. In this video, I will teach you how can you use technology, but you must pretend that you don't know that, and you must show your work. I will tell you how can you obtain all these values, so this mean and this standard deviation, using technology. Let's do first a simulation with Applet. Listen, in Applet, you can find a lot of applet that can help you to understand several concepts in a statistic. For example, in this case, let's use this earned sampling. Let's simulate with this earned the problem of all households in the United States, and we define as success all households that have 3 or more cars, and failure the rest. Suppose that in the United States we have 100 million of households, to say one number, and from these 100 million of households, 35% have 3 or more cars. Then suppose in this earn we have success 350 millions. Then the complement of 100 million is 650 million. Let's simulate. The red will be success, green will be failure. And let's select from this earn, if we put all name of the house in one bag, 400 name, 400 household. And we are going to determine in how many cases we will obtain more than 162 success from 400. Then let's run 1. In this sample of 400, we got 138 success. We are expecting 140. If the proportion is 35% of households that have 3 or more cars, if I got 400, 35% of 400 is 140. That is my expectation. Then in this particular sample, we obtain, if we hover here, we obtain, and we can view it, we obtain 138. It's close, it's very close. Let's take another sample. 400, we got 148. That is my new sample of 400 households. In this sample of 400, 138 have 3 or more cars. Another sample. In this case, we obtain 151 success. Another one. In this case, we obtain 156 success. Another one. We obtain 130 success. Let's run 5 samples simultaneously. 5 rounds. 1, 2, 3, 4, 5. Can you see all of them were close to 140, because that is my expectation. Let's run right now 1,000 simultaneously. 1,000 sample, all of them 400, and we are going to count the number of success in all of these 1,000 samples. That is the result. Can you see that the samples with more than 162 success are located in this red region? 162 is here. Then how many of these samples from in total 1010 samples, in how many of them we obtain more than 162? Here in this sample we obtain 6 with this value between 162, 61 and 63. Here in this we got 10 samples. Here only 1, I guess. Exactly, no, 11. And here 13. Then in total, you can sum all of them, and 1010 samples. That cases are unusual. That is the way we can do a simulation. In this case, we do a simulation. We select a few number of samples. But what happens if we take all possible samples of the same size, 400, from this population? Let's do the binomial theoretical distribution. And let's go to stat. In stat, let's go to calculator. In calculator, let's go to the theoretical binomial distribution. In this theoretical binomial distribution, consider all possible samples. Then suppose that my sample size here is 400 and the probability of success is 35%. I want to find what is the probability to obtain one sample such that the number of success in this sample is at least 162. That is the probability. The probability is actually very small. This probability is 0.012. If you transform this in percentage, is 1.3%. Actually, is less than 5%. Is located in this region. We can input these 2 points in this graph, and let's verify that between 120 and 159 we have approximately, this is empirical rule, we have approximately 95%. Let's do it. Let's select between. When we select between, we can input here 120.9, and here let's input 159.1, and let's obtain the probability or proportion of sample in which the number of success is between 121 and 159 out of 400 is 95.9. The empirical rule estimates 95%, but this is the exact percentage. If we select all possible sample size 400, 90, approximately this is 96%. 96% of all samples are between this and this number of success. The center is, can you see? The center is exactly 140, my expected value. Actually, when I select one sample, the sample could be located approximately here, close to 140. Most of them are located here. Few samples are located in this tail and this tail. For that reason, these samples are unusual. Okay, you can use technology to solve problems, but you must pretend that you don't know it. And you have to show your work in this way. That is your work. You need to write down formulas and intermediate results.